Mr. Sachin Bansal is here now. His topic is now everybody we are touching upon mostly on the batteries and things like that. I think he is going to touch on the powertrain.
Okay, good afternoon, everyone. So thanks, Dr. Raghuraman. I think he pointed out right thing about the safety of the batteries and the e-vehicles. So I'll also touch upon those points and then share some of the knowledge and ideas probably we can use in manufacturing of these EV powertrain components to make them more safer, more rugged, more reliable, like the ICE engine components. So we have seen these all in the news. There have a few incident of the fire happened on different type of vehicle. It happened two-wheeler, four-wheeler, and in the buses as well. So what this incident has drawn is drawn the attention of the government to implement or to announce certain regulations which should drive the EV battery manufacturing companies to implement so that the future generation e-vehicles become more safer, more reliable. Because these vehicles are related with you and me. As a passenger, we use them and it has to be safe because it's impact the human life. So glad that government has announced these norms in September, and those norms which is called under AIS 156 amendments. And as per the guideline of the government, these norms has to be implemented by March 23 by the all EV battery manufacturers. So what these norms talks about primarily is, first of all, the key thing is the thermal propagation test, which is the key element of this EV battery and is a demand from all the battery manufacturers. They have to submit these batteries, they have to get this certification of thermal propagation, and then only they will be allowed to use these batteries in the EV vehicle after March 23. So what is this thermal propagation test? It basically is all about prevention, detection, and reporting. Okay, so they have to use certain elements. First of all, it will prevent that to happen. Second thing, if at all it happens, they should have some elements which will detect, and end of the day, those elements should report in the vehicle, like on the panel and all, what is happening in the vehicle, what is the temperatures and all, so that at least the end users get alarm of if something is major is going to happen in the vehicle. Elements. So in prevention side of it, as we see the thermal runaway, okay, so it's a technical term, but I will explain. Like thermal runaway is like the heating of a particular cell, okay? So every battery pack is made of individual cells, which can be in cylindrical or in other forms. But these cells can become a thermal runaway in condition by overheating or overcharging or maybe short circuit in the battery or maybe different reasons. So when this happens, we call it as a thermal runaway situation, okay? So thermal runaway situation, as you see in here in the individual cell on the upper picture, there's an individual cell which is going into the thermal runaway situation. So that is where the problem is. And once these individual cells enter into that, it can also propagate or transfer that heating to the next cell. And it can have a cascading effect in the entire battery pack. And that's where the battery can explode and can lead to the fire in the vehicle. So that is how is the phenomena which we have seen in the actual battery incident. This could be the one of the possible reason that those battery pack were not having that prevention at first place to prevent those thermal runaway situations. So in cell cases, what we do is the thermal runaway can be happen. Generally, we have been interacting with a lot of EV battery manufacturing companies, and most of the companies were not thought of this situation earlier, okay? And they have not designed those battery pack that they will use certain chemicals to prevent those thermal runaway situations. Few companies were already knowing that, they have taken care in the design phase itself, but most of the companies, they were new to these phenomena, they were new to the battery designing. Of course, they were the engineers and scientists, but this is something new phenomena, they were not estimated. So when this happened, they realized this, yes, they need to do something about designing. They have to use certain chemicals, okay, to prevent those thermal runaway. So there are certain chemicals available in the market. There are several companies who are promoting these chemicals which will prevent those thermal runaway, and also the chemical will also dissipate the heat. Okay, because you are charging and discharging the battery, the heat will generate over a period of time. So to prevent the heat, their chemicals are available in the market which will dissipate the heat, and also it will prevent the thermal runaway situation of the cell. So now this is the encouragement from the government, and it is mandating all these battery manufacturers to now seriously think about preventing those thermal runaway or thermal propagation situations. Unless otherwise, their battery will fail in the testing. So all these battery manufacturers, now we are working with them, doing them trials and demonstration, helping them to qualifying these materials so that they can use in their manufacturing processes. So there are various processes as you see here. These cells are encapsulated by chemicals. So these chemicals are encapsulating the cell around it, so that if at all any cell when goes into thermal runaway, it will not lead to the next cell. So it will prevent the thermal propagation. But there are other chemicals also available which will also dissipate the heat. Which means it will also reduce the chances of getting the individual cell into the thermal runaway situations. So as a Graco, we play the role here is to help into the manufacturing process by dispensing those chemicals into the manufacturing process to help to make the battery more safer, more reliable. Can you just play the video? So this was all about the manufacturing solutions for encapsulating the cell. So there are various chemicals where you can encapsulate and you can prevent. Now next thing is in AS 156 is also the IP67 compatibility, because this is again related to the water ingress into the battery pack. Because particularly in two-wheeler batteries, there can be a chances they are already exposed to the environment, and in the rainy season you don't want water go inside the battery pack, which is again being electrical in nature, can be dangerous. So all these battery pack now has to be IP67 compatible, and for doing that there are various chemicals available in the market which can be used for having the liquid seal. I'll share that all the ICE engines currently use this liquid gasket currently. So this same concept has to be implemented into EV batteries as well, because essentially it's again is a EV engine for us. So there is a battery pack, as you see in the purple seal. This is basically the liquid applied gasket instead of the rigid gasket, which is more flexible. It takes the shape of the groove so that it is more seal. It takes the seal the entirely, and it is more better for the water ingression than the rigid gasket. So that is what the another new concept. Can you just run the video?
So we're here in the Graco, Ohio Applications Lab today, and we're looking at a very common application for us for battery and electric vehicle. This is the battery pack seal. This is a really critical seal in any type of electric vehicle or battery pack. It prevents water from getting in the pack, which can create corrosion, which can create fires and things like that. So this is a very critical seal for EV manufacturers. And today we're dispensing a one-component cure-in-place gasket. So this material is dispensed in the bead around the perimeter of the part, and it's very critical that the bead dimensions are maintained throughout the dispense. So we use a robot and also our PCF system which will control the flow rate and guarantee a high quality uniform bead all the way around. This particular material is heated, so we're using a ThermoFlow 20 to feed the PCF and then dispensing with a robot around the perimeter of the battery pack seal part. You can see here that there's a nice consistent bead. That's exactly what we're looking for.
As you've seen in the video, these liquid gaskets are very flexible. You don't need to spend energy always when you change the design to spend on mold and all. And again, you are dependent on your vendor quality processes, whether the gasket is giving you are rugged or how much tolerance they have between different gasket. But liquid gasket are flexible, and then you just keep changing as per the profile. You don't need to go to your vendor for any change. Now after that, then we come to the module assembly. So you put together the different cells and plates to make as a one module. So in that, again, you have different processes like bonding the different cells together, and then maybe the putting the cell on the cell holder. You need to apply certain adhesives to bond the cell with the substrate. So again, we give the dispensing system over there. And once you make the module, you put them into the frame and you make it a battery pack. So where you assemble different modules based on the size of the battery. Of course, two-wheeler batteries are smaller, so you may have generally two modules. But generally in the four-wheeler or on the buses, you have a bigger battery pack, so you have more modules to assemble together to make it as a battery pack. So in that, again, as I talked about, you need a heat dissipating materials because you are putting modules. So there would be heat generated over a period of time because of charging, discharging. So you need to apply certain chemicals, certain adhesives, or certain thermal management materials which can we can dissipate the heat as it goes along. So that is again the phenomena which is getting catching up with the manufacturers to use in the production processes.
Industry is making the switch to electric-driven vehicles, and batteries need to be safe, high-performing, and lightweight. In assembly processes, repeatable and accurate dispense is critical to meet those requirements. And there, Graco has got you covered. For applications such as cell-to-carrier bonding, foam encapsulation, gap filling, structural bonding, pack seal, and fireproof coatings, Graco has you covered. And with worldwide customer and innovation centers, Graco provides quick and custom support for your application and design optimization needs. For battery assembly applications, power up with Graco.
So again, in powertrain, you have several components like motors, chargers, and controller. Again, to make them more reliable, more rugged, as we talked about, Dr. Raghu talked about the BMS. Again, BMS has PCBs and all, which need to be protected against the outside environment like dust and water. So again, there are chemicals available for potting of those PCBs, sealing, and thermal management systems. So we give an entire system for all the EV powertrain components. So we have a Graco technical center. If you want to try or experiment with these around battery manufacturing process, trying different chemicals, at this technical center, we do the trials and demonstration, do the proto for these manufacturing processes. You can contact us. So do visit our booth here in the Expo A2, and we can talk more in detail. Thank you. Thank you very much.
May I request Marcus to just come over and give a memento to. If you really become rich man, probably we may not even call you for this before you become so rich. Thank you.